Well, hello everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. Yeah, it's 11:18. Yeah, I said 18 instead of 18 on the East Coast, and we just had a crazy ass winter storm, or just kind of storm. So I had to wait until that passed. At the same time, I passed out because your girl is crispy. Yes, she is burnt. She is ready to die, ready to fry. But before I pass on, we're going to learn a little bit about graphing linear equations. Yes, a lot of you guys are having some trouble with the graphing, so why not? Let's get started with this. Okay? Of all the things, graphing, it is a step-by-step process. So all we have to do is, if you're ever given an equation, we need to set up a table. That's it. That's all it is. We just need some x-axis or x values to plug into our equation so we can find the y values so you can get the point. So, if you're still here with me, yippee! I know, we're all back into it. So, cat, wait, you've been sleeping this whole time. Now start talking, now you want to come over here. I know. Alright, so this is what we're looking at. We're looking at y equals 3x minus 7. Alright, hold on, gotta get the cat out. Come on, you. I love you. I know. I'll be back. We'll be done before you know it. Alright. So, I just picked any values that made sense. And this is usually the part that everyone gets confused on. Like, what should I put for the x's? I don't know what to write. This is all you have to do. You just put in some values that's going to make sense so you can draw a straight line. So, some people like to have like -2, -1, 0, 1, and 2. But I know if I put anything negative in here, I know I'm going to get a negative as a product. And if I subtract it with the -7 or subtract it with 7, I'm going to get a bigger negative number. If that makes any sense whatsoever, okay? I told you, I was asleep. So anyway, I just wanted to actually get something that's going to be positive so my graph is not going to be so ginormous. So all we are doing is we're doing 3 times, and my value, let's say 0, minus 7. So 3 times 0, 0. 0 minus 7, that gives me a -7. So you just created a point of value. So the ordered pair is going to be 0, -7. Okay? So all we have to do is when you graph, you start at the origin. Now, they're saying that my x value is 0. That means I'm not going left or right. I'm just staying right here at 0. Then I'm going to go down 7. And here is my point. Also known as my y-intercept, because it's crossing the y-axis. So if I do this again, I'm going to plug 1 in for the x. So that means we have 3 times 1 minus 7. So 3 times 1, that gives me 3. So 3 minus 7, that will give me a -4. So your order pair is going to be 1, -4. So when it's time for you to graph, first point, you should be putting your pen or pencil right here at the origin where the intersection is. Now, they're saying I need to go to the left 1. Do not put a point there. We have to complete the movement. So you start at 0, go to the right 1, then you're going to go down 4. Now you're placing your point. Okay? So same thing over here. This time, instead of an x, we're going to put a 2. So 3 times 2 gives me 6. 6 minus 7, that gives me a negative 1. So your ordered pair for the next point is going to be 2, negative 1. Starting here at the origin, I have to go to the right 2, 1, 2, and then down 1 and plot my point. A lot of people will do, oh, I have to go to the right 2 and then put a point. No, don't do that. All right. Now, just by looking at the red dots, I'm starting to see a nice line. All right, last one but not least, we have 3 times 3 minus 7. So 3 times 3, that gives me 9, minus 7, that will give me a 2. So the ordered pair is going to be 3, 2. So again, you're starting at the origin. You're going to go to the right 3, 1, 2, 3, and then you're going to go up 2, 1, 2, and you're going to make your point. All right. So now, we're going to draw our line. And that's how you graph your line, okay? That's how architects are making their designs. That's how you figure out that you need something either straight or you might use some curve, all right? So here it is. All right, Zaddy, you're an adult? Why do you have to claim that you're an adult? You need a reminder that you're an adult? You're hilarious. You never applied any of this in life? Well, what have you been doing with your life? Because math is everywhere, baby. All right? Too much work? Lazy? Come on, let's go. Can you borrow my brain? Hey, sure. All right? So, when it comes to graphing those linear equations, like guys, if you can't see it from the slope-intercept form, that y equals mx plus b, okay? If it's already a slope-intercept form, which I have one that's not, so you can deal with that. But all you have to do is really look at my y-intercept, which was negative 7. So 0, negative 7, that's my y-intercept. Then I'm looking at my slope. My slope is a 3. Anytime it's a whole number, you're putting that whole number over 1. So that means I'm going up 3. 1, 2, 3 over 1. Hey, look at there. There's that point. If I go up 3, 1, 2, 3 over to the right 1. Oh, look, another point. Oh, piece of candy. 1, 2, 3 over 1. Oh, piece of candy. Okay? So they're all on the same line. So you always think of your y-intercept as the starting point, where you start on the y-axis. Your slope is going to give you the rhythm to draw the next point. We try to make this whole thing super complicated. Yeah, we could throw a lot of terminology out there, but it's really this simple. Okay? All right. So let's take a look at our next one. Okay, so we have x. We have some values of x. Then we have 7 minus 2x. Okay, so a lot of people say, well, is that in slope-intercept form or is that in standard form? Well, take a look. If it's standard form, that means your x and your y is on the same side, the equal sign. Be it with the number, be it without a number. But this is what's happening. We're going to pick some points that's going to make sense for your graph. You do not have to have this huge, ginormous graph. So, if we take a look, we have our 7 minus 2 times my x. Okay? I figured, hey, let me put one negative in there. Let's see how that goes. And then I'm going to put some other numbers. Notice, I went from negative 1, 0, 1, 2 to a 5. What a rebel I am. Skipping over 3, 4, right? Just going straight to 5. You can do that. Hello, you can do that, okay? So, if we plug in my negative 1, this is what's happening. I have 7, then I have a negative 2 times a negative 1. A negative times a negative is a positive. We have that so engraved in our head, it's not even funny. But the problem is we forget to apply it. Okay? So when you have a negative times a negative, it gives me a positive, and 2 times 1, that'll give me 2. So 7 plus 2, that'll give me 9. And what happens is you just found an ordered pair. So your ordered pair is the negative 1, that's your input, and your 9, that's your output. You plugged in the negative 1, you came out with the 9. So if we're going to graph that, starting at the origin, then I go to the left one, because it's a negative 1, and I go up 9. Yeah, because right here is a 5, 6, 7, 8, 9 should be all the way up here. Okay. So now, ignore this one. Doesn't exist. All right. So now we're doing the same thing, but this time with the 0. So we have 7 minus 2 times the 0. Now, anything times 0 is 0. Now, 7 minus 0 gives me 7. So our order pair is going to be 0, 7. And that 0, 7, that is my y-intercept. All right. Okay. All right, so we got our 1. This time we're plugging in 7 minus 2 times 1. 2 times 1 gives me 2. 7 minus 2 gives me 5. So our ordered pair is going to be 1, 5. All right. So starting here at the origin, we're going to go to the right one, then we're going to go up 5 to make our point. What grade is this for? Algebra. Okay, could be for algebra. Please zoom out. Algebra. Okay, could be for algebra. Please zoom out. I didn't even zoom in. Olivia's like, zoom out. I'm like, I didn't even zoom in. All right. So, hey, Lynette. So, if anything, we have 7 minus 2 times 2 this time. Okay. 2 times 2 will give me 4. 7 minus 4, that's 3. You see how simple? All we're doing, plugging in for our x values. And sometimes you just got to read the equation. So here I'm starting at 0. My x's, I'm going over to the right 2 since it's a positive 2. And then I'm going to go up 1, 2, 3. All right. And then last but not least, we got our 7. We got our 5. I just saw the 7 and it just came to me. So I'm going to plug a 5 in for the x. So now we have 2 times 5, that gives me 10. So now you have 7 minus 10. 7 minus 10, that'll give me a negative 3. So our order pair is going to be 5, negative 3. So again, starting at the origin, we're going to the right 5, and then we're going to go down 3 to plot our point. Even though it wasn't a nice little even ride with the x's, it never is when you're messing with the x, it always gives you a straight line. Okay? It's all coming back to you. I know, it's just like riding a bike, you know? What you gotta do? Ooh, I got Mega following me. Eee, how exciting. That's when you know you're famous, guys. That's how you know. I'm telling you, that's how you know. Well, welcome on in. How's it going? All right? So, basically, this is what you're doing. Okay? This is all you're doing, especially when you're dealing with linear equations. Now, again, if this was, which it is, because it was originally y equals 7 minus 2x, it was in that slope-intercept form. Now, here's the thing. The coefficient of your x is always your slope. Okay? That's always your slope. So that means the 7, that's my y-intercept. That's where we started right here. So then my slope is a whole number, so it's minus 2. Anytime it's a whole number, put it over a fraction, because slopes are naturally fractions, rise over run. So from your y-intercept, you're going to go down 2, 1, 2, and it's a positive 1 to the right 1. Bam, there, piece of candy. Down 2, 1, 2, over 1, boom, piece of candy. Down 2, 1, 2, over 1, it would be a piece of candy. Down 2, 1, 2, over 1, there's another piece of candy. Down 2, 1, 2, over 1, piece of candy. All right? It is that simple. Hey, hey. What you hear? No problem. I know, right? Like, ooh, piece of candy. Ooh, piece of candy. Ooh, piece of candy. All right. So, of course, tonight, not really all about, hey, here's the love and all this attention. If you can tap, that'll be awesome. Hey, that's fine. Today's going to actually, or tonight, I should say, is going to be a short one. Right? It's always like you want a piece of candy when the stores are closed. Isn't it weird? I don't know. Something's open. There's a Walgreens somewhere. All right. So, as we're getting ready for the next two, because I'm really, as I said, I'm going to make this short and sweet. Now, today was supposed to be the start, but of course, you know me, I kind of just jumped the gun with some stuff, but I am still going to be consistent with this right now. So if any of you, see again, didn't screen up. If any of you are going to get your GED, your ASVAB, your TEAS test, your college algebra, and you would like to do a mock practice test, like really dedicate yourself to sitting down, okay, on a Zoom call. You're going to be working on the practice test. It'll be like 59 minutes, okay, 35 questions in total. And then afterwards, I'm going to go over the test so you get a better idea of what areas you may need to work on a little bit more. And plus, to lessen that test anxiety. You guys keep making these exams like a representation of you. No, make the test your B, okay? Like really. Just don't let this test get in the way of your life, okay? You guys understand the concepts. You want to understand the concepts. You want to apply the concepts and go ahead and do it, okay? Do not let that whole when am I ever going to use this in life? Well, right now, baby boy and baby girl, you need this in order to have a life. You get tired of struggling, you want to get into the military, you want to become a nurse, you want to be a teacher, you want to do whatever you want to do, you don't want to have to work 3 or 4 or 5 jobs making little to nothing, you want to probably have a job that makes a little bit more, you're going to have to jump through their hoops, baby. You're going to have to jump through their hoops, and that's real talk. So let me help you lessen the pain and anxiety of getting this test done. All right. So again, if you come live, subscribers to my channel or non-subscribers is $10. Then if you want the replay and the copy of the test as well as the copy of my notes, that's going to be $25. But for my subscribers, you're going to have a discounted price of $15. So made that decision. If you're interested, just go. I gotta tell you where to go. Just go. Sorry, there's so many things I gotta flip. I can't say it, but I can show it. Go here. Right? If you click my face, you'll see this. But go here, and there's actually a link to go there. All right? All right. Okay. All right. Now, let's get started. So, if anything, this time, our equation is negative 3x minus 6y equals 0. So right now, it's not in slope-intercept form. Yes, you probably could fill in a couple of values of x's and figure out your y's. True. But it would be nice to know what I could use to make my life easier. So the reason why, I'm going to solve this for y. When I solve for y, see, now I'm going to zoom in. Whoop, there you go. All right. So if I solve for y, I can put it in that slope-intercept form. So first thing, I'm going to add 3x on both sides. So I have negative 6y is equal to 3x. I don't have to put the plus 0. Okay? Not necessary. 0 is a placeholder. And right now, since there's something already on that right-hand side, I don't need a placeholder. But the next thing I need to do is divide both sides by negative 6. The reason why I'm choosing the negative 6, because right now that's the coefficient of my y. And I want y by itself. So now I have 3 over negative 6x. That can be simplified. Okay? 3 and 6 can be simplified to... She's back. Yes. Yes. A little late. Okay, very late. We were having a storm, and I wasn't sure if my electricity was going to stay on, yes or no. And plus, I fell asleep. It's been a long day. It's been a long day. All right, so bring it down. 3 and 6, what they have in common, they both have 3 in common. So 3 divided by 3, that will give me a 1. Negative 6 divided by 3, that will give me a negative 2. And I bring down the x. So this is what I'm using for my table so I can draw my graph. Now, I'm going to show you one of two ways. So since my denominator is a 2, even though it's negative, but it's still a 2, you want to use x values that are even, because you can divide it so much easier than a 1 or a 3 or a 7. Then you're going to have to deal with fractions. And you know how you are about fractions. You don't like them. All right? So I'm going to plug in my 1 over negative 2x. Okay? Because I'm going to put some input. So I'm thinking about, okay, we can do a negative 2. I can do a 0. I can do 2. And I can do 4. All right. Now, if you have a teacher that says I need 5 points, you can either do a negative 4 or you can do a positive 6, so you can make your whole 5. All right, but remember, all you need is 2 points. Okay, the minimum you need to draw a straight line is 2 points. So all we're doing is substituting. So we have 1 over -2, and we're multiplying by -2. Think of it this way. Ready? Everyone's like freaking out. You don't have to freak out. First of all, a negative times a negative will give me a positive. Okay, so I know my answer is going to be positive. But what is half of 2? What's half of 2? Put it in the chat. What's half of 2? I know you feel like I'm like threatening your intelligence. There we go, Annie. Thank you. Okay. Is that Polsey? Okay, saying 1. Yes, 1. Netta. Good. 1. Lizzie. Yes, 1. Okay, so you just found an ordered pair. The ordered pair is -2, and your output is 1. So you're starting at the origin. You're -2, that means I'm going to the left 2. Your y is a positive 1, so I'm going up 1. And I'm plotting my first point. Okay? So, next one. We have our -1/2. This time we're multiplying it by 0. Anything times 0 is 0. So my next point is right here at the origin. 0, 0. Okay? I know you're probably like, man, that went quick. Yeah, of course. All right. So now here we go. -1/2. This time we're multiplying by 2. Again, we're taking half of 2. But this time we have a negative, and this 2 is a positive. So that means my answer is going to be negative. Then I take half of 2, which again is 1. So your ordered pair is going to be 2, -1. So starting at the origin, going to the right 2, 1, 2, and down 1. Draw your point. And last but not least, we have 1 over -2. This time we're multiplying by 4. We have a negative times a positive. That means my answer is going to be negative. And then what's half of 4? 2. So my ordered pair is the input was 4, and the output is going to be -2. Starting at the origin, going to the right 4, but down 2. All right, good. So now you have that. Draw your line, okay? I'm gonna try. Because for me, I always get this weird glare. All right. Now let me zoom out. There you go. Okay, so sometimes when you get these in any kind of test, even in the class, if they give you an equation that's in standard form, the reason why I know it's standard form because my x and my y is on the same side of the equal sign. If they give it to you in standard form, you can put it in slope-intercept form and then try to graph it. Okay, here I don't see a plus or a minus, so that means my y-intercept is going to be at 0. That's what we got right here. Then I'm looking at my slope. I have a positive 1, so that means I'm going up 1, and then a -2 to the left 2. Boom, piece of candy. okay? But remember, with negative slopes, one or the other can rock it out. So if I wanted to, I could say this equation is y equals -1 over positive 2x. So that means if I start here at the origin, I can go down 1, but I'm going to go to the right 2. Boom, piece of candy. Okay, go down 1 to the right 2. And you just repeat that. If I wanted to go up 1 but to the left 2, up 1 and to the left 2. That works as well. We just need at least 2 points to draw our line. All right. Where did the -1 come from? If you're multiplying by, okay. So, a positive times a negative, when the signs are different, your answer is always going to be negative. So that's where the negative came from. Now, we're taking half of 2. If you got 2 things and you want to say, all right, let's split it up, that means you're giving 1 thing to each person. Half of 2 is 1. All right. All right there, cheeseburger in paradise, you good? All right. Okay. All right. So now, the last one. So the last equation, we have 1/3 x plus 4. Now, if you have somebody that's saying, yeah, you gotta fill it in using the table. Okay, I know I can look at this and graph it without using a table because I have that y-intercept, which is a positive 4, so that's 0, 4. But then I have my slope. That means I rise 1, that means I go up 1, and I go to the right 3 to draw each point after my y-intercept. But sometimes people say, you know what, I want you to calculate it. Okay, fine. This is what you need to do, especially when you have fractions. Everybody always wants to put like -1, +0, +1, +2, and then you're going to get frustrated because you've got to deal with fractions. So since my denominator is 3, deal with x's that are multiples of 3. Trust me, okay? So if I wanted to do, say, some negative ones, so I'm going to say -6. I'm going to say a -3. I'm going to say 0. I'm going to say 3. Okay? Because I want to deal with numbers that are multiples of that denominator. Because I'm going to be taking 1/3 of it. When you take 1/3, you're basically dividing by 3. So if I plug in, we're going to have 1/3 times my -6 plus 4. So that's what's happening here. Now, if I say -6 divided by 3, that's going to give me a -2. So now I'm going to take that -2 and add to 4. So -2 plus 4, that will give me a 2. All right. So my ordered pair for this one is going to be -6, comma 2. All right. Hopefully this is making sense. So the reason why I use multiples of 3 because it gives me a nice clean answer. So if I go here, I got my 1/3. And this time I plug in a -3. So 1/3 of -3. This is positive, this is negative. So I know right away my answer is going to be a negative. And if I do 3 divided by 3, that's going to give me my 1. Then I bring down that plus 4. So -1 plus 4 is going to be 3. The reason why, the signs are different. When the signs are different and you're adding and subtracting, that means you're really subtracting. And you're taking the sign of your largest number. Or, let's be simple. Okay, you owe me $1. You paid me $4. That means you overpaid me $3. That's a blessing. Thank you very much. Okay? Now, anything times 0 is going to be 0. So we take this 0 and then we add it to the 4. So my answer we got is 4. So the order pair for this one is 0, 4, positive 4. That's my origin. Okay, not my origin. That's my y-intercept. Yeah, this is why this is my last one. And very similar to the -3, this time we're putting a positive 3. So a positive times a positive will give me a positive. A third of 3, that will give me my 1. 1 plus 4, that's 5. So my order pair here is going to be 3, 5. How do you calculate a third plus 4? Well, you got to change your 4 into having a common denominator. How did I get 3, 5? The x is 3. You take a third of the, that gives you 1. 1 plus 4 gives you 5. No. Why are we using -6 and -3? Okay, so since my denominator is a 3, only Gene just because it's you. All right, so because my denominator is a 3, we want to use multiples of 3s. Because if I use a 1, I'm going to deal with 1/3. You guys don't like fractions. If I use a 2, that's going to give you 2/3. You guys don't like fractions. So why not use numbers that are multiples of 3 so you can get a nice, clean, even answer? Okay. All right. Well, thank you. Glad I can be someone's fave. I haven't been a fave in a minute. So, why do we use negative versus a positive? Just to give you a better range. Okay, just to give you a better range. Because I'll show you in a second when I graph up. It's like, yeah, don't fear the negative numbers. So 1, 2, 3, 4, 5, 6. All right. So starting at the origin, first point is going to be -6, 2. So that means I'm going to the left 6 and I'm going up 2. Draw my first point. Then we have -3, 3. So I'm going to the left 3 and then going up 1, 2, 3. Starting at the origin, we're at 0, 4. So we don't go left or right, we just simply go up 4. And lastly, starting at the origin, our next point is 3, 5. Go to the right 3, because it's a positive 3, and then go up 5. And then you can see our nice little line. Looks like it took more time for me to draw the graph than to actually do the graph. And that's how you graph linear equations. No problem. Yeah. Because if you do all positive, like, yes, you are going to get something, but sometimes it's nice to get a little bit from the negative side and a little bit from the positive side. That's all. All right. Nice. So, yeah, that's all I really wanted to do tonight. It's almost midnight. All right, cool. Well, thank you. I appreciate that. Very nice. I know. Didn't know. Something wholesome. Break up the monotony of midnight foolishness. You know? It's not like BET After Dark back in the day. Oh, back in the day. All right? So you just try to keep it simple when it's time for you to graph. Okay? You can put it in slope-intercept form. Like here, this was already in slope-intercept form. I start with my 4. Right there. There's my y-intercept. And then my slope tells me where to go to draw the next point. So since it was 1/3, that means I go up 1 and over 1, 2, 3. Piece of candy. Okay? Now, the best thing about positives, both of them can be negative for a positive slope. Remember, a negative divided by a negative is a positive. So I could go down 1 and then over to the left 3. 1, 2, 3. Ooh, piece of candy. Okay? So it can work for you. Don't let the equations work you. You work the equation. Right? All right, cool. Exactly. As long as you keep the same pattern. If it's a positive slope, that means both the numerator and the denominator has to be negative. If it's a negative slope, just like how it was for this one, you get to choose which one's going to carry the negative. Is it going to be the numerator or is it going to be the denominator? Okay, so you get to pick and choose which one takes it. All right. Cool. All right, everyone. So hopefully this is not going to be too treacherous. If you do like my notebooks, I do have my notebooks on sale. You can just go straight to that other. Everything I am doing is all here, okay? But if you also need tutoring, if you also need courses, it's all here, okay? Especially for the notebook, I didn't have to use my factor sheet this time, which was kind of nice because I have a whole bunch of factor sheets from 1 to 200, also the rules of integers, order of operation, properties of exponents, okay? We have properties of quadrilaterals, then also some other references that will help you with Algebra 1 and even Algebra 2 or pre-calc with the unit circle. All right. So if you have any questions, if you had some questions about the mock practice test, please make sure, just message me. Okay. Other than hi. Okay. Say something else. Like, hey, Audrey, I saw your live. I'm really interested into the mock practice test. Can you tell me more? Boom. Something like that. Okay? Now, if you missed out, if you've missed the beginning of it, all of my lives are here. Go here. Okay? Once you go there, this is the thing I want you to do. I want you to do this. I want you to do this. I want you to do this. Definitely do that. And do this, okay? So all of my lives from February 2nd is listed there. So if you need any assistance, you just need like certain things. You might want some examples of not only how to graph an equation, maybe how to do the quadratic formula, maybe know how to do completing the square, or maybe just something as simple as adding, subtracting, multiplying, or dividing fractions. It's there. Okay, whole plethora of information. Okay. Okay. So to get the book, if you go, just click on my picture. This should be one of my links. Okay. So you got that as an option. So books are there. It's called the Ultimate Math Notebook. So I have the books there, I have the tutoring sessions there, I have the courses there, basically almost everything. All right. Not a problem, thank you. Okay. All right, any questions? At the university? Good. Okay, awesome. All right, so give me some time to see how this will upload, and I'll be able to put this bad boy and what I did yesterday evening, because that just downloaded from late yesterday. Ridiculous, but here we are. But I'll be putting up last night's and tonight's on, yeah, that place. Here. Because I can't say the word, God forbid. All right, so if anything, I will see you guys tomorrow at 1 o'clock. Not sure what exactly I'm going to be doing, but I know it's going to be math related. And we're going to have some fun doing it. All right, so have a great morning if you're on the East Coast. Great evening if you're everywhere else. And I will see you guys tomorrow. All right? Okay. How long the tutoring sessions? Up to an hour. Yep, up to an hour. And right now I'm running a summer special until the end of this month at $47. My sessions are normally $87. So take advantage of it. Okay, you're so welcome. All right. Because I know a lot of people, if they're taking college algebra, some people, their finals are coming up either next week or the week after. Because I think some people are having their exams on the 30th or the 31st. So, all right. Sweet. All righty. Okay, so I will see you guys tomorrow. For me, later on today. All right, take care, guys. Have a good night. And don't stay up too late scrolling.